Hi everybody, in this video we're going to focus on solving equations that contain rational expressions. So basically equations that have fractions in them. And we're going to take a little bit further though here. So we're going to start with a few review examples where all the denominators are just numbers, but then we're going to bring in some examples that actually have x's in the denominator as well. So that's where they get a little bit slightly different than the regular ones. Now, in all cases, we do solve these equations by canceling the fractions. So we're going to use common denominators to multiply through those equations and get rid of those fractions right away. The only thing is when we have variables in the denominator, in particular, we have to be super careful because we could actually get what are called extraneous solutions. So those are answers that don't actually work. So that what happens by multiplying through by additional factors is you sometimes create extra answers that are not true answers. So you do have to always check your answer in the original equation to make sure it works. And then, of course, also watch out for dividing by 0 here, because we cannot have any answers that would cause division by 0. So the big takeaway with rational expressions is that we're going to just treat them like regular fraction problems, but we do have to really check our answers in the end and make sure that we get solutions that actually work. So this first one here, you can see that I don't have any x's in the denominator. So it's just kind of like a regular fraction problem here. And what we're going to do is you're going to find the LCD first. So if I look at 2, 3, and 6, the least common denominator would be 6 there. Any common denominator is fine, but the smallest one you can get, the better, because it's just going to keep your numbers lower. And then what we're going to do is we're going to multiply both sides by 6. So what happens is you multiply the left side by 6. And the right side by 6. Now, as a little shortcut here, and I'm going to start doing this in the other examples, is what's going to happen is you're going to distribute that 6 all the way through. So what you're really doing to save a little bit of steps here is to just multiply each factor or each term by 6, and that works as well. So 6 is going to get multiplied by x over 2. It's also going to get multiplied by 8 over 3, and then by 1 over 6. So if you want to write out the step here, because technically you are multiplying both sides by 6, you can, but you can also just remember that, well, that 6 is going to get distributed through, so it's really just going through each of the different terms. Then what happens is you're going to cancel the denominator first. So I'm going to do the division here. 6 divided by 2 is 3. 6 divided by 3 is 2, and 6 divided by 6 is 1. And if you picked a correct common denominator, they should all cancel out perfectly. So you shouldn't have any weird answers here. And then you'll multiply what's left over. So 3 times x is 3x, 2 times 8 is 16, and 1 times 1 is 1. And then now you should have a regular problem that you can solve. I'm going to subtract 16 to both sides. I get negative 15. I'm going to divide by 3, and I have my answer of negative 5. Now, as you're going through here, I'm just going to go back to my notes for a second. You're going to go ahead and now check this. So you can either check it by writing all the steps out, or if you want to just check it mentally, that's okay too, or on your calculator. But you really do want to get in the habit of checking those rational problems because they do have sometimes extraneous solutions that don't actually work. So what you're going to do to check this is you go back to the original problem always, and you plug in the original solution there and see if it actually gives you a true statement. Now, if I'm adding fractions, I do need common denominators. So this one I can multiply by 3 over 3, and this one by 2 over 2. That would give me negative 15 over 6 plus 16 over 6 equals 1/6. And now you can see that it does check out. Negative 15 plus 16 is 1. This is going to check out, and negative 5 is a true solution. All right, let's try one more that just has numbers for the denominator. I have a 2, a 9, and 18 here. So my least common denominator is going to be 18. And again, I'm going to multiply both sides by 18. But the shortcut to save a little bit of work is that you're really just going to multiply each term by 18 because you're going to have to distribute it through. So the first group will get multiplied by 18. The second group will get multiplied by 18. And the third group. And just be really careful here. that subtraction sign you need to watch out for as it comes down. And again, we multiply each term. So because this is all stuck together as one piece, it just gets the 18 one time. You don't put the 18 like multiple times throughout. So with each term. And then you're going to go ahead and divide. 18 divided by 2 is 9. 18 divided by 9 is 2. And 18 divided by 18 is 1. Now, if you can do this in your head, go ahead. I like to write this out because it's a little bit more complicated. I have a 9 left and a t minus 4. I have a minus 2 left and a t minus 3. And then over here, I just have 1 times 5 is 5. But on the left here, I'm just going to take my time. That 9 and 2 have to get distributed through. So it's going to be 9t minus 36. Watch out, this is a negative 2 coming through, so negative 2t plus 6. 9 minus 2 is 7, so I have 7t. Negative 36 plus 6 is negative 30. And then I'm going to go ahead and keep solving. So I have 7t equals 35. Divide by 7, and I have t is equal to 5. And again, take that moment and check your work. Go all the way back to the original and plug in that 5. So I have 5 minus 4 over 2, 5 minus 3 over 9. So that's 1/2 here minus, let's see, 5 minus 3 is 2, so minus 2/9. I do need common denominators, so I'm going to have to multiply this first one by 9 over 9 and the second one by 2 over 2. So I have 9 over 18 minus 4 over 18 equals 5 over 18. And this does work, right? 9 minus 4 is 5. So this one does work out. You are going to notice that when you don't have any x's in the denominator, you're not going to have extraneous solutions. So that's a little tip here. It's still good to check your work to make sure you didn't make any mistakes. But in general, as long as you haven't made a mistake here, then your answer should check. When we get into trouble is when we start having x's in our denominator, like this next one. That's when those extraneous solutions can really start to pop up. And those are the ones we have to be the most careful about. So here, my only denominator is an x. So this is going to be my LCD. Now, if you are having trouble here, you may want to go watch videos on how to add and subtract with rational expressions, because it does review how to find the LCD there. So this one's pretty simple. I only have one denominator, so that's my LCD. But as we get into more complicated ones, if you need to review how to find the LCD for rational expressions, please go and watch those videos. So I'm going to multiply both sides by x, and with distributing through, it's going to be x times 3, x times 6 over x times x, and then x times 8. Now, the only fraction I have to clear out here is this x over x is just going to be 1, right? So that clears out, and I'm left with 3x minus 6 equals x squared plus 8x. All right, I'm going to get everything to one side here. So I'm going to bring everything to my right side. I like to keep the x squared positive when I can. I'm going to do this at the same time. So I have a 0 on the left, x squared plus 5x and plus 6. Now you're going to notice that we do have a quadratic here, meaning you have a square. So the way we've been solving these, there's lots of ways to solve them. So again, you're welcome to use different strategies, but this one here is going to be factorable. So notice that how it's equal to 0 to start, and I can factor the right side. Again, if you need to review how to factor, you can go back and watch some of those videos. The way that this one will factor is as positive 2 and positive 3 here, and you can always check by multiplying it back out and making sure it matches. And then once you have your factors, you can set each factor equal to 0 and solve. So here I subtract 2 from both sides. Here I subtract 3 from both sides. And I have my 2 solutions here. Now you are going to have to check both of these answers to see if they actually work. So let's do our checks off on the side. I'm going to start with x equals -2. So I go right back to the original. 3 minus 6 over -2 equals -2 plus 8. Be careful here, you have those two negatives which will cancel. 6 over 2 is 3. So I have 3 plus 3 equals -2 plus 8. This does work out, right? You do get 6 equals 6. So the first one is good. I'm going to go ahead and check the second one here. So let's check -3. So I have 3 minus 6 over -3 equals -3 plus 8. Again, watch out for those negatives. I get a +2, and this one also happens to check out. I get 5 equals 5, so they're both good. Now, also notice here that for the domain, the only issue we'd have is that x cannot be 0, right? Because that would make the denominator 0 here. So I'm not getting any of those issues here, and they both check out perfectly fine. So these are both valid solutions in this case. All right, so next we have some more complicated examples here. In this top one, you can see that the bottom is not factored yet. So as you get more complicated, if you do have denominators that are not factored all the way, like these are fine, there's no squares there, nothing in common. But this one has a square here, you're going to need to factor that first in order to find the LCD. So when I factor that, it factors as, let's see, x and x. That 30 will factor as 6 and 5, and I do want that 6 to be positive there. Now, don't forget, if you have subtraction or addition, then that is stuck together, right? So those denominators are really one piece here, all stuck together, x minus 5, x plus 6. So the LCD, in this case, if I look at all my factors here, I need to have an x plus 6, and I need to have an x minus 5. And if I have both of those factors, that will include all of them. So remember, if you're struggling here, there's videos on factoring and on finding LCDs for rational expressions. So you need to be comfortable with that already before you get into the solving piece. Now I'm going to multiply both sides by my LCD, which means I'm going to multiply each term by my LCD, or each different piece. So I'm going to start here, x plus 6, x minus 5, and that's getting multiplied by 4x over x plus 6, x minus 5. I multiply the second piece. And on the other side, I multiply the last piece. So these can be a little bit long. You just need to take your time with them. And now I'm going to cancel what's in common. So notice here the x plus 6 cancels and the x minus 5. So you're just left with a 4x. In the next case, though, only the x minus 5 cancels. So I have a 2 and an x plus 6 left. And then the last case, the x plus 6 cancels, and I have a 1 and an x minus 5. So here I have a 4x left. Here I have an x plus 6 and a 2. And on the other side, I have an x minus 5 and a 1. You are going to distribute that 2 throughout. So you have 2x plus 12. Here, multiplying by 1 doesn't change it, so it's going to stay as x minus 5. And I'm going to keep cleaning this up. So let's see. I have 6x plus 2 equals x minus 5. I'm going to subtract the x to both sides. Move over here. And I have 5x plus 2 equals, let's see, negative 5. Oops, sorry, I wrote this wrong. Let me fix that here. 2 times 6 is 12. That should be a 12 there. I apologize. I knew I was missing something in my writing. So just be careful. I make mistakes too. 6 times 2 should be 12, not 2. So that would be 5x plus 12 there. Now I'm going to subtract 12 from both sides. And I get 5x equals negative 17 and divide by 5. So x equals negative 17 over 5 as our solution. Now, one thing to note here, and I'll let you guys check this one at home. This one actually does check out. So if you plug it back into the original problem, you are plugging it way back here at the start. You're going to want to use probably your calculator there to help you. So you're just making sure that left and right are the same. So I would use my calculator here. Maybe even make this a decimal form and just plug it in and make sure it checks. The other thing you want to note as well is that if you look at your denominators here, my two main issues are x plus 6 and x minus 5. So if you think about having your denominator be 0, we need to make sure that x is not -6 or positive 5, right? Those would be the two values. If I plug them in, that would give me a denominator of 0. So that is not this value here. So we're not seeing any denominators that are 0. If I plug in -17/5, it's fine. And if you do plug this in, it does check out on both sides. So again, watch your denominators, make sure you're not creating any values that divide by 0. And then I can always solve these two. So if you're not sure where I'm getting this from, I'm just solving x plus 6 and x minus 5 not equal to 0. So I'm looking at all my possible denominators, and those are the only two factors I see.